Hi, thanks for joining me. Today I'm going to be going over problem 1 from week 7 of the Invariants Summer Puzzle Competition. As always, I'll leave a link in the description below to the Facebook page of the Invariants where you can find more details of the competition. Now this is the problem I'm going to be tackling today, and it's a little bit technical to state. I've left a full statement of the problem in the description below, so I've only kind of written the key points here, and I'll try and explain the problem as best I can with an illustration as well. But if that confuses you, perhaps read the read the full statement of the problem in the description below, and hopefully then you'll be able to understand the problem. Anyway, let me try my best to explain it. We have 2 sticks, and each stick has 2 to 9 red slots, and all the other slots are blue. And I've written 3 dots here because I'm going to try and explain the rest. We want to prove that the final number is composite. Now, what number am I talking about? Well, here I've got an illustration of kind of how this problem works. So here is an example. So these are our 2 sticks, and as you can see, this top stick here has 3 slots. And this bottom stick has 1, 2, 3, 4, 5 slots, like so. And as you can see, some of them, in this top stick, some of the sticks, slots are red and some are blue, and similarly for the bottom stick as well. And also notice that we've got 2 red slots here and 3 red slots here, and both 2 and 3 are in that interval there, 2 to 9. Okay, so we've kind of got this first line covered. Then what I'm going to do is I'm going to take my 2 sticks and put just the final slot of the top stick and align it with the first slot of the second stick, like so. And then what I'm going to do is, after each second, I'm essentially going to bring this bottom one and slide it across one, and then slide it across another one after the next second, and so on, all the way up until the the first slot of the top stick and the last slot of the bottom stick align. Okay, and what you might notice here, I've written some numbers down, and those numbers are going to correspond to the numbers we're talking about in this problem. And this here, this 0, 1, 2, 1, 1, 1, 0, is going to be our final number. But I'll get into that in just a second. What we're going to do is, in the first second, we're going to look at all the slots that are overlapping. So in this case, it's just these 2 here. And ask ourselves, well, how many have red in both slots? Well, we haven't got red in both slots here, so that's just 0. So we've written down a 0 here. The next thing we do is we slide this across, so we get this kind of picture here. And then we ask ourselves the same question, how many red slots align? Well, these 2 don't, because we've got a blue and a red. But these 2 do. We've got one kind of pair of red slots aligning, so we're going to write a 1 after that. Then what we're going to do is, again, bring this bottom slot stick across, or we can think of it as bringing the top one to the right, it doesn't really matter, and we're going to get this picture here. And again, we're going to ask ourselves, how many red slots align? Well, we've got these 2, that's 1, and we've also got these 2, that's another. Now, even though these are 2 of the same colour aligning, we don't care about those because they're not both red. If they're both blue, or one's red and one's blue, we don't care about them. We only care when both are red. So in this case, we've got 2. So we write 2 after the number, after the numbers we've already written. So we're kind of introducing a new digit at each kind of shifting across. So we get 0, 0, 1, 0, 1, 2, and we repeat this process all the way until we bring this top stick all the way across, and then its first slot is aligned with the second stick's final slot. Okay, and then here you can see we've got a red and a blue. So that corresponds to 0. So I've omitted the 3 1s, but hopefully you can see where the 3 1s are coming from. If I bring this across one more, then this will be with this blue, so it won't align. This blue will be with this red, so it won't align, but this red here will be with that red, so that will be this first one, and then you get the other 2 ones using a similar sort of argument. Anyway, you get to this last one here, and you can see the red and blue don't align, so we get a 0. And this here, what we're going to do is firstly ignore any leading zeros, so in theory we just get rid of this 0 here. And now what we're going to do is think of this number 121110, which is what, 121,110. That's going to be our final number, and what we want to do is prove that that number is composite, so it's not prime. And hopefully in this case it's very clear that it's not prime because it's divisible by 10. But yeah, that's the problem we have for today. If you want to have a go at the problem, please pause the video now and give it a go for yourself. And if you do want to have a reread of the problem, check it out in the description. Anyway, I'm going to get stuck straight into a solution. Okay, so the solution to this problem is a little bit fiddly, and the way I'm going to solve this problem is kind of working with the example I have already written down, and then kind of illustrating why this final number can't be prime and must be composite. And yeah, so I'm not really sure if there's a better explanation / better solution to this problem, so if you do have one, let me know in the comments down below. Anyway, the way I'm going to prove that this final number here must be composite is to kind of generate 2 positive integers, which are strictly bigger than 1, and they're going to be associated to these 2 numbers here, and I'm going to prove that when you multiply them together, you're going to get this final number here, and of course that will mean that the final number can't be prime and hence must be composite. So what are these two numbers? Well, I'm going to associate a number to the top stick, and let's say I'm going to call that A. And the way I'm going to work out A is I'm going to put a 1 for every red, and then a 0 for every blue, so I'm going to get 1, 1, 0. And then I'm going to reverse that, so I get 0, 1, 1, which obviously is just 11 in this case. So of course this is just working with this particular example, but the argument holds in general. Then for my bottom stick, I'm going to associate the number B, and the way I'm going to do that is pretty similar, except I'm not going to reverse it. So for all the reds, I'm going to put 1, and then for all the blues, I'm going to put 0, and then, yeah, just write it down. So I've got 1, 1, 0, 1, 0, and I'm not going to reverse it. So with A, I do reverse the digits, but with B, I don't. And I claim that when I do A times B, I'm going to get that final number. Now, I guess one quick thing is to note that A and B can never be 1, and the reason for that is because we're going to have, they're both going to always be at least 11, and the reason for that is because they always have at least 2 reds in, and that was kind of in the statement of the problem. They have to have between 2 and 9 reds in, and hence they're always going to have at least 2 ones in, so they're going to have to be at least 11. Okay, so A and B are going to be positive integers which are at least 11, so strictly bigger than 1, so A times B will certainly be a composite number, and you can go ahead and multiply these two numbers here and check that you will get this final number here. But I'm going to hopefully illustrate why that's the case. Okay, so let's write down what we have for A kind of a bit more clearly here. So remember, we took our number for A was 1, 1, 0, then we reversed it. So this thing here is kind of in my hundreds column, because I've got a 0 there kind of. This thing here is in my tens column, and this thing here is just in my units column. Okay, so the number we have associated with A is 0 times 100 plus 1 times 10 plus 1 times 1, which gives us 11. And then for B, this thing here is 1 times 10 to the 4. This thing here is 1 times 10 cubed. This thing here is 0 times 10 squared. This thing here is 1 times 10 to the 1. And this thing here is 0 times 1, or 0 times 10 to the 0. Okay, so that kind of corresponds to B and the associating digits in it. And then essentially what we're going to prove is that A times B, when we kind of do this process of bringing this slot along, counting the number of reds that align, we're going to kind of prove that this process is the same as if we were to do A times B and kind of multiply them using long multiplication, and then hence obviously we'll get our final number. So let's just perhaps illustrate that with the first step. So notice that we already kind of know what our final number is. It's that guy here. Now what we're doing in our first step is we're just seeing how many of the blues and reds align. In this case it is 0, and that corresponds to 0 times 1, which we know is 0, and that's why we write down 0 here. And I guess one thing to also point out here is that, remember, at each step we're counting the number of red slots that align, and now notice that 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, and 1 times 1 is 1. So the only way we can multiply two numbers from the set 0, 1 and obtain a non-zero number is if we do 1 times 1, and that will give us 1, and that kind of corresponds to, you know, the only way we can kind of write down a non-zero digit in here is if we have 2 reds aligning. So yeah, if we have any blues involved whatsoever, that's going to immediately essentially write down a 0. Anyway, so we get this kind of process here, and let's move on to the second step. So now we do have the reds aligning, and they have a blue and a red. Now let's copy down what we have here. We have this thing here corresponds to 10, and this thing here corresponds to 0 times 100. And this thing here is what, 10 to the 4, and this thing here is 10 cubed. Now here we're going to get 10 to the 4 times 10. So we're going to get a 1 there, which goes in that kind of point there, and that corresponds to that 1 there. But notice that that's in the 10 to the 5 column, which corresponds to that 10 times 10 to the 4. So that thing there, 10 to the 5. And obviously if this blue here was a red, so suppose it was a red, then this thing here would be 1 times 100 times 1 times 10 cubed. And of course that is another one, that's another 10 to the 5. So that would make this one here a 2, which obviously we'd get anyway because we'd have 2 reds and 2 reds. So we'd write down a 2 there. So hopefully you can start to see that essentially what we're doing is we're comparing the reds and the blues in such a way so that each time we move across, we're getting another digit, and that corresponds to kind of the next power of 10 down. And to work out what that is, it's essentially just counting the number of reds, but that's equivalent to, you know, if we marked up the reds as 1, which we have, and the blues as 0. Okay, so hopefully it's starting to make sense. Let's do another digit, so hopefully it's a bit more clear. We've now moved our top one all the way across, all the way to the first one's aligned, second one's aligned, and the third one's aligned. And again, let's write down what we have. This one here corresponds to 1. Let me get rid of this. This thing here corresponds to 10, and this thing here is 0 times 100. 10 to the 4 is here, 10 to the cubed is there, and that's 0 times 10 squared, and so on. And here, 10 to the 4 times 1, that's going to give us a power of 10 to the 4. And 10 cubed times 10 is going to give us another power of 10 to the 4. So that's why we write a 2 in the 10 to the 4 column. Okay, and then of course we've got 0 times 10 squared times 0 times 100. So that gives us, well, if they were both red, then that would give us a 1 times 10 squared times 1 times 10 squared, which obviously would be another 10 to the 4. So we'd get a 3 there, but of course we don't, we have 2 blues. Okay, so this process continues, and we get to our final one. And now remember, this thing here is our 1 times 1, and this thing here is our 0 times 1 for our bottom number. And of course, 1 times 0 is 0, and that's why we get a 0 there. So hopefully that's all, and yeah, we get our final number. So hopefully that's all made sense. Yeah, I'm not really sure if there's a better way to explain this problem, so I apologize if everything wasn't super clear. But essentially, it's, you know, once we work out what A and B are, sorry, and we have written it down, we can kind of see when we slide them across where each of these digits are coming from. And now one small technicality, which is thankfully accounted for in the initial statement of the problem, is that we must have the number of reds being less than or equal to 9, because if we had more reds, if we had more than 9 reds, then we could have some carrying over. So for example, suppose, you know, you had both of your slots being just 9 reds and, you know, 9 reds, and when they both align like that, then you would have, sorry, if you had 10 reds and 10 reds like that, then of course in theory you should have a 10 in one place, but of course 10 isn't a single digit, it's 2 digits, so you'd get carrying, and there'd be some issues with that. So that's why we have to have the number of reds being at most 9. Anyway, I apologise if that hasn't been crystal clear. Hopefully someone in the comments can help my explanation, perhaps thinking of this in another way. But if it has made sense, I'm glad it has. Thank you for watching. I'll catch you in the next one. Have a great day.